so today what we're going to do is we're going to practice some exponent rules. I feel like your math teacher last year kind of introduced this to you, but we're going to just do it again for sure because this is algebra, okay? So we're going to learn about some math properties, okay? The first one being, what if I have, maybe instead of doing numbers 1, 2, and 3 first, it'd be easier to do number 4 first, okay? So go ahead, Emily. So do you see how right here for number 4, so we're doing number 4 first, okay, guys? I have 7 to the 5th times 7 to the 8th. Holy cow, that's a huge number, okay? But do you see how I have the same base? I have a 7 and a 7. So here's a trick. If I have the same base, all I have to do is add my exponent. So I have 7 to the 5th plus then just 8 because my exponents are the 5 and the 8. I can use this trick because my bases are 7s. They're the same number. So 5 plus 8 is 13. So that's my final simplified answer. Now, some of you might say, do I really have to figure out like what that answer is? That's a huge number. So if it's a huge number like this, I mean, it's going to be like 9 billion, blah, 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 blah. No, just leave it like this. But if your answer is like 7,000, then sure, just write 7,000. Okay. So for number 5, you have the same base, 3 and 3. So the rule is if you have the same base and you're multiplying them, you can actually just add the two numbers. So do you see how I'm adding -2 plus 7? I'm just adding my exponents. So what's -2 plus 7, guys? 5. So 3 to the 5th power. 3 to the 5th power is much smaller. It's 243. So yeah, I mean, technically 243 is totally possible for you to write as an answer. Okay, so let me tell you why that trick makes sense. Let's say I have 2 to the 3rd times 2 to the 5th. I know that my answer is going to be 2 to the what? 8. But why? Okay, so if I have 2 to the 3rd, isn't that just 2 times 2 times 2? If I have 2 to the 5th, isn't that 2 times 2 times 2 times 2 times 2? So how many 2's do I have? 1, 2, 3, 4, 5, 6, 7, 8. That's why my answer is 2 to the 8th. Like if I were to separate it all and then count them all up, don't I just have 8 total? That's why that trick works, okay? So now let's do it with, variables. Okay, so I can't just type my answers in my calculator because now I have letters, but that's okay. I have the same base, x and x. So if I have the same base, the trick is I add my exponents. So I'm adding what plus what? 3 and -5, so I end up getting -2. That's not my final answer. But because what did I learn yesterday? If I have a negative exponent, it can be simplified. Does anyone remember what is actually then my answer? Luke? Not 1 over 2.
Oh, 1 over x.
Yeah, 1 over x squared, right? I have to flip it. So what did I learn yesterday? I can't just leave it as to the -2. I have to flip it and then it's simplified. Okay, so now let's do number 7. Okay, the rule only works if I have the same base. So can I add this 2 with the a with anything else in here? No, right? Because there's no more a's in here. So that stays the same in my answer. I can't combine any of the a's. But my b's I can combine because they're the same. So combine your b's. What do I end up getting? B to the what? 4. And so my final answer is a squared, b to the 4. Again, there's not too much work to show today, right? And that's okay. As long as you're getting the right answer and you're trying it yourself, I think that you can kind of make that decision yourself. Do you get it? Do you not? Let's do number 8. Oh, look, I have an N, I have an N, I have an N. They're all the same. So start adding all of them up. Does anyone think they know the final answer? Rowan?
Just N.
Just N. Or you can say N to the 1, right? Which is the same thing as saying N. So either way is fine. 5 plus -1 is 4. 4 plus -3 is 1. That's how Rowan got 1 or just N. Same thing. Yes, Owen?
If it's N1, wouldn't it, you just write 1 because anything the exponent is, or that's 0.
Yeah. Okay. Let's do this one now. So I have R's. Okay, so I have 2 R's I can combine. Does someone think they have this final answer? Ashlyn?
R2 and 5.
Oh, look, and you even wrote it in alphabetical order. Good job. So please try not to write S5, R2, because it's not in alphabetical order, right? So R to the second, S to the fifth. The S to the fifth stays the same. The R is -4 plus 6 is 2. Okay, let's go back up to number 1. Yes, Mason?
So on number 8, would N1 be the wrong answer?
No, N1 is fine, or just N. Either one is fine. Okay, this one is weird. I have A's, but I don't have numbers. I have letters, but that's okay. Does anyone think they know how I can write this with all these letters? Read.
A-N-A-M?
No, like you can still combine it somehow. The rule is I add the exponents. Vaughn? Not MN, because that'd be multiplying them. Yeah. So if the rule is you're just adding them, well, you can't add an M and an N because they're different letters. So just write it out separately, M plus N. Okay, that's my first rule. My second rule is going to be this. All right, now do you see how I multiply, or not multiply? Do you see how I have like a power to a power? I have something to the third power, but then all of that is to the fourth power. So like this, I have something to the 0 power, but then all of that is to the 5th power. So here's my trick. If I have a power to a power, I multiply my exponents now. So I'm multiplying 3 times 4. So what's 3 times 4? 12. So it's 2 to the 12. That's my answer. Okay, so that's my rule. So here, if I have a power to a power, I multiply my exponent. So it's 4 to the 0 times 5. So that's 4 to the 0. Is that my final answer? No, because I can simplify. What is 4 to the 0? 1. Okay, so please keep that in mind. If you can simplify it any farther, make sure you do. All right, so number 12. I get b to the -8, but that can be simplified because it's a negative exponent. Emily?
1 over the 8.
Yes. So do you see how, like, even though I did the rule, I can still simplify it even farther? Okay, so here's the reason why this multiply works. Okay, so let's go back to number 10. I had 2 to the 3rd all to the 4th. So isn't 2 to the 3rd to the 4th the same thing as saying what's 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd? Because I have this 4 times. Well, isn't 2 to the 3rd 2 times 2 times 2? This is 2 times 2 times 2. This is 2 times 2 times 2. This is, oops, 2 times 2 times 2. So how many 2s do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, that's why I multiply to get 2 to the 12. Okay, that's why this rule works. That's why that trick works. So back to number 2. I get a to the m times n, so mn. You can say m times n, or you can say mn. All right, let's make it a little bit more complicated now. Let's go to number 13. For number 13, do you see how I have 2 things in parentheses now? So if I have 2 things in parentheses, all to a power, this is my rule. The first thing I do is I have to add exponents to things that don't have exponents. So do you see how the 3 is to the imaginary 1 and the n is to the imaginary 1? Like if I don't have an exponent there, I got to put them in there. Now, the next thing I do is because there's 2 things in the parentheses and not just 1, I basically have to like distribute. So I'm taking this 4 and I'm distributing it to both things. So if I'm distributing, I'm multiplying. So I have 3 to the 1 times 4 is 4, n to the 1 times 4 is 4. So my final answer is 3 to the 4th, n to the 4th. Some people, because they're like, 3 to the 4th is small, it's just 81, they'd rather have you write it like this. Honestly, I'll take either answer because I mean, normally, if it's a smaller number, like in the thousands or the 10,000, sure, just write it out. But if it's like in the billions or trillions, then just leave it as an exponent. Okay, so for number 14, same thing. If I don't see exponents, give me exponents first, imaginary ones. I'm going to take the 3 and I'm going to distribute. So in other words, I'm going to multiply. So I get 2 to the 1 times 3 is 3. X to the 1 times 3 is 3. So 2 to the third, x to the third, which is really just 8x to the third. Okay, so let's go up to number 3. So that was the trick that we just learned. If I have a and b, so write exponents first. That's a to the 1, b to the 1. Take the n and distribute it to everything in there. So I get a to the n and then b to the, okay. We're good so far? You remember learning this last year?
No.
No. Oh, okay. I feel like this is something that you would have learned in like May and June, or not, I guess it's May. It's one of the things that like normally after the STAR test, your 7th grade teachers would have taught you, but I think because of COVID and all that stuff, they didn't get to like kind of prep you for algebra as they normally would, but that's okay. We're doing it now. Okay, let's do number 15. Now it becomes a little bit more complicated. Here's the thing. Let's follow PEMDAS. PEMDAS tells me to do exponents first, then do multiplication, right? So do the exponents first, then do the multiply. So if I do the exponents first, I get t to the 12, because 3 times 4 is 12. That's the trick, times t to the third. Now let's do the multiplying. So my final answer is t to the 15, right? Because now I add. So do you see what I did? I'm kind of combining my rules together. If you are the least bit confused, or if you're very confused, iExcel V4, V5, those cover this, like really, really basic. So V4 and V5 is something great for you to practice right now. Well, not right now, but this week. All right, so number 16. In PEMDAS, they tell us to do exponents first, then do the multiply. So I end up getting b to the 8 times b to the 9 times b to the negative 2. That doesn't change. Now what do I have to do with 8, 9, and negative 2? Add them all. So 8 plus 9 is 17 minus 2 is 15. Okay. Number 17. PEMDAS tells me to do exponents first, then I do the multiply. So I get a to the 6 times a to the negative 6. Now I multiply. So I get a to the 0, right? Because 6 plus negative 6 is 0. Is that it? No, it equals 1 because anything to the 0 power equals 1. Okay, number 18. I have, PEMDAS tells me to multiply first, or sorry, exponent first, then multiply. So I get c to the negative 10 times c to the negative 6. Now I can multiply, so now I add them together. What's negative 10 plus negative 6? Negative 16. But I can simplify that because that's a negative exponent. So what do I actually end up getting? 1 over c16. Good. I hope you're kind of following along. It's not too difficult. Number 19. All right. The volume of a cube can be found by this formula. Basically, take your side and cube it, right? Length times width times height. So if each side length is that, find the volume. So aren't I doing 4a squared b to the 4th all to the 3rd power? Because here's my side, and I'm multiplying it by itself 3 times. So let's practice that. First thing, remember, is if I have lots of things in my parentheses, give exponents to things that don't have exponents. A has an exponent, B has an exponent, but 4 does not. So it's 4 to the 1st, or 1. Now take the outer 3 and distribute. So 4 to the 1 times 3 is 3. A to the 6, B to the 12. If you really wanted to multiply out 4 to the 3rd, that's just 64, A to the 6, B to the 12, right? But I would honestly take either one. Okay, if you didn't think that was complicated enough, look at the back side. Okay, here's another rule. This is a 6 and a 2. I know that the copying is not so great. Here's my next rule. Do you see how I'm dividing now with the same base? I have a 3 and a 3, but I'm dividing them. So the trick is, if I'm dividing them, I actually subtract the exponents. So 6 minus 2 is 4. So my answer is 3 to the 4th, which equals 81. So for this one, number 2, it is, I can't even read. I think it's A and it's 5. B to the A over B to the, oh, it's an 8. 8 and 5. Okay. All right. So what do I have to do with 8 and 5? Minus them. So what's 8 minus 5? 3. So that's my answer. I don't flip it because it's not a negative exponent. Ooh. Yes, Ashlyn?
Wait, why are you subtracting to the multiple?
Because here's the trick. If I have 3 to the 6 over 3 to the 2, I subtract, 6 minus 3 is, or 6 minus 2 is 4, right? Why? 3, 3, 3, 3, 3, 3. I have 6 threes. 3, 3. I have 2 of them. If I wanted to cancel it out, isn't 3 divided by 3, 1? 3 divided by 3, 1. So how many do I have left over? I have 4 of them left over. That's why my trick is to subtract them. Yes, Reed?
Oh, wait, never mind.
Okay. All right. So let's do number 3. I have t to the 2 and then t to the 7. So I subtract them, right? So I get t to the negative 5, but that's not it. 1 over t to the 5. Or you can think of it this way. You have t, 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 t. So if I just like cross it out like how I showed Ashlyn, that cancels out, that cancels out. You have nothing left on top, so you have a 1. How many t's do you have on the bottom? You still have 5 left over. I mean, you can think of it that way too. Okay. This is just the beginning, guys. Isn't it so exciting? Okay, so PEMDAS tells us that I do exponents first, and then I can do my multiplying or dividing. So my question is actually s to the 3, t to the 4. I'm not changing the top because I have to do exponents first. But on the bottom, I have s to the 6. Okay. Now, remember how we said you can only change things or use a trick if they have the same base. So I have s's that I can change. So if I have 3 on top and 6 on the bottom, how many do I have left over? 3, but would it be on the top or bottom? Like, does that make sense? Like, if I were to list off 3 on the top and 6 on the bottom, I would still have 3 left over on the bottom. Or just think 3 minus 6 is negative 3, so negative 3 gets flipped. The t to the 4th, it just stays where it is because it wasn't a negative exponent. So that's my answer. Okay, number 5. Okay, PEMDAS tells us exponents go first. So exponents, put ones where we don't have exponents. And then you take that 2 and you distribute. So on top, I have a to the 1 times 2 is 2. B to the 1 times 2 is 2. Okay, on the bottom, you're taking the 3 and then distributing. So on the bottom, you have a to the 15 and then b to the 6. Okay, so you can think of it 2 different ways. You can just think, imagine 2 a's on top, 15 b's on the bottom. How many do you have left over? 13. Would it be on the top or the bottom? The bottom, right? Because you had more on the bottom to begin with. Or think 2 minus 15 is negative 13. Negative 13, boom, it gets flipped to the bottom. So for the b's, how many do I have left over? 4, top or bottom? Bottom, because 2 minus 6 is negative 4. Negative 4, boom, it gets flipped. So what do I put on top? Just a 1 as a placeholder. Okay. Let's do number 6. PEMDAS tells me to do exponents first. So I have to take this 2 and I have to distribute it. So on top, I still have x to the 3rd, y to the 1. That hasn't changed. On the bottom, I have x to the 6, y to the 6. Okay. Oh, 4, 4, 4, 4, 4. Silly rabbit. Come on, Friesenhahn. 2 times 2 is 4. All right. So my x's, I can combine. I have 3 on top, 4 on the bottom. How many do I have left over? 1 on the top or bottom? Bottom. Okay, the y's. I have 1 on top, 6 on the bottom. How many do I have left? 5 on the top or bottom? Bottom. And then just 1 as a placeholder. Okay, last thing I want to show you is now yes, Tessa? Yep. I have a fraction. I have a fraction. Okay, if I have a fraction, here's the rule. Same thing. If you don't have exponents, put exponents in there. And then take the outer exponent and multiply. So I have 2 to the 1 times 4 is 4. 3 to the 1 times 4 is 4. Yes? Yeah. And then I have 2 to the 4th is 16. 3 to the 4th is 81. And then just make sure that 16 over 81 is a fraction that you can't simplify. 16 over 81, oh, it's still 16 over 81. So I'm good. Okay, let's do number 10. We're going to kind of have to skip around because we don't have too much time left. Okay, for number 10, negative exponent. Do not flip, guys. Do not flip before you actually distribute because you're going to get yourself so confused. Flip at the very end. Okay, so first of all, I have to the 1 to the 1. Take the -2 and multiply. So do not flip, do not flip, do not flip. Let's just write it all out. So I have 4 to the 1 times -2 is -2. 5 to the 1 times -2 is -2. Now I can flip. Okay, the 4 goes to the bottom because it was a negative exponent. The 5 goes to the top because it was a negative exponent. So I get 25 over 16. Okay, if that's not difficult enough for you, let's do number 12. Isn't this so exciting? This is what math is supposed to be like. All right, number 12. This is all to the -3rd power, by the way. All right, so first thing you need to do is think. Do not flip, do not flip, do not flip. That confuses you. Just distribute the negative and then flip. So you have 2 to the 1, b to the 1, c to the 1, 3 to the 1. And then distribute, 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 distribute. Okay, so I have 2 to the 1 times -3 is -3. b to the 1 times -3 is -3. That's the top. On the bottom, 3 to the 1 times -3 is -3. c to the 1 times -3 is -3. Now that I've listed it all out, let's start flipping. You see how if everything is a negative exponent, like the tops go to the bottoms go to the top. Does that make sense? Okay, so 2 to the 3rd goes to the bottom. B to the 3rd goes to the bottom. And then the bottom, C to the 3rd goes to the top. 3 to the 3rd goes to the top as well. Okay, I know that the C's and the B's I can't simplify. I can't subtract, but maybe I can simplify that. 3 to the 3rd is 27. 2 to the 3rd is 8. 27 over 8 cannot be simplified. So that's just my final answer. Okay, that was really tricky. So guys, your homework, the front side is pretty basic. It was like the front side. It doesn't get too hard. The back side is where it gets a little bit more challenging, especially like 13, 14, 11. So try it. But again, if you get it wrong, we'll go over it tomorrow. Okay, so online kids, go ahead.